Hello, my name is Chad Varney and I'm an application engineer here at Ally PLM Solutions. I'd like to welcome you to our first NX CAM Lunch Byte session. As you may know, we've had NX CAD Lunch Byte sessions for quite some time. And I'm excited to start the new NX CAM Lunch Byte sessions. We have several of you on the line with us today, so you'll be in listen-only mode for this session. If you have any questions, after the session, you can email them to me at chad.varney@allyplm.com. I want to remind you that we have all of our Lunch Byte replays up on our website, and you can check those out at www.allyplm.com. We want these sessions to be valuable for you, so you can send your topic suggestions to us by going to our website under NX Lunch Byte section, typing in your name, email, and topic request. Today's topic is setting up your workpiece in NX CAM. It's very important not to overlook how to properly set up your workpiece. Setting up your workpiece correctly in NX CAM is just as important as setting up the actual part out on the machine. It's critical in machining to start with the right setup on the machine out on the shop floor, because we know that if your part's not set up correctly to begin with, there could be major issues down the road. In the same way, in NX CAM, we should look at some things that will ensure a good setup or a good foundation to start from. So today we're going to take a look at these topics to better understand how to properly set up our workpiece. First, we're going to look at how to start manufacturing in NX, and we'll look at two different options. The master model concept versus just opening a design model, or just our master model and selecting start manufacturing. Next, we'll look at wave linking your part geometry. Then we'll talk about each different option for creating blank geometry. Then we'll look at using synchronous tools to create blank geometry. And lastly, we'll look at how to reference an existing IPW or in-process workpiece as our blank geometry. So let's get started. First, we're going to look at two ways to get started in the manufacturing environment. Each company is different and handles their manufacturing data differently. So I want to make you aware of both options. Now, the first option is simply by opening up a part and going to start manufacturing. As we can see here, I've already got a part open, and I'm just going to go to start manufacturing. And we'll notice that the machining environment dialog comes up. And this is basically just a template selection to help us select the proper setup for the type of part that we're going to machine. For now, I'm just going to use the mill planer options. Alright, so you'll notice if I go to create an operation, the only options that I have available are mill planer operations. There's no contour milling operations or anything else. There's drilling operations, hole making, and mill planer. So basically just 2.5 axis operations are available, and that's because we selected the mill planer template. All right, so you might think, well, what if I want to do some contour machining, in these pockets? I selected the mill planer, and you could do that as well if you know that you're only going to be doing planer milling or just regular drilling. That's a good way to keep things simple by having the least amount of options possible. But if I do want to do some contour milling and I've already selected this mill planer, still no problem. All you have to do is go to Preferences, Manufacturing, and under the Configuration tab, just reset your configuration file and your template set. And you'll notice now I have all of these options available. So now I have mill contour available. All right, but what I really want to point out here is if we take a look at our assembly navigator, we notice that we just see triple clamp. That's the name of this part here. We see that in our assembly navigator, and that's all that's in our assembly navigator. This is not an assembly. So this means that after we create our operations, our tools, our tool holders, and save this file, then all of that manufacturing information will remain in this file, this main triple clamp file. We know that NX saves files as a .prt, whether it's an assembly, drawing, or even a manufacturing file. So if you want all of your manufacturing operations, tools, tool holders, all of that information to be in the same part file, you would probably want to use this method by just going to start manufacturing. All right, the next option we're going to look at is what I would refer to as maybe the master model concept, where we have a design model or a master model that was maybe released from an engineering department or a design department. And maybe we don't want to change anything in that model since it was released from a designer or an engineer within our company. We would want that model to remain unchanged. We want it to remain the design model or the master model. As we can see here, I've got the same file open, but what I'm going to do now is just go to File, New. All right, and we can see under the Manufacturing tab, we notice that this selects millimeters as our unit, and that's referring to our triple clamp part, so it automatically selects that for us. One more thing that we'll notice is that this makes our file name, it defaults to _setup1, so that puts setup1 in our file name. Of course, we could change that if we wanted to, but it makes NX goes ahead and puts setup1 in our file name. You also notice we have template options here. I'll go through each of these template options, just talk about them just a little bit. Our general template, and you can see over here in a preview window, general has basically all the options available. You could do milling, turning, 5-axis, whatever you want. It has all the options available. So if you don't mind having a lot of options, the general setup would be good for you. Die mold setup for mold and die work, like 3-axis contour milling, any kind of contoured part milling, this would be a good template for that. Turning, this will only have our turning operations available under the turning template. Machinery template, this is similar to the planar option that we looked at earlier. This is for 2.5-axis milling, drilling, just basic planar style work. Multi-axis is 4 or 5-axis machining work. Anything to do with multi-axis work, your operations will be available in this template here. If you got a part that you're going to do milling and turning, like on a mill turn machine, we've got a template for that as well. Then we also have a simulation template. For now, I'm just going to use the general template. All right, so now what we'll do is we'll take a look at the Assembly Navigator. Again, I just went to File, New, and we'll take a look at the Assembly Navigator, and we'll notice that triple clamp _setup1 is the parent, and triple clamp is the child. This is the same way we would see an assembly named as the parent and a component named as the child. So when we create our tools, operations, tool holders, and save this file, NX will save this under the _setup1 name, and the design model remains the same. It doesn't contain any manufacturing within that model. So it's up to you which of these two different options that I just showed you that you prefer. It basically comes down to selecting the right template and then deciding if you want your manufacturing data in the same file as your master model, or whether you want it in a different _setup file. All right, next we're going to look at wave linking our part geometry. It's a good practice to wave link or create a copy of our design model. By creating an associative copy, we can manipulate the linked geometry without changing the design model. So I'm going to create a wave link body and then use synchronous modeling to manipulate the model to get it ready for machining. All right, so I'm going to take this model and create a wave link of this model. Notice that associative is turned on and hide original is turned on as well. So this is going to hide this original model, and then this is going to be associative to that original design model. All right, so when I hover over this, we see that this is our linked body. This is not our design model. This is a linked body. So I can make changes to this based on whatever I want to machine. So I'm just going to make a couple of changes to this. You may want to do, like, if you're machining like a plate or something like that, has a lot of cutouts or holes in it, and you're just wanting to mill the surface of a plate, you could use synchronous modeling and delete those holes out of your linked body. So that could be kind of your manufacturing model instead of your design model. So I'm just going to go over to the modeling environment here, and I'll delete these chamfers around the outside of the part and around these pockets here. And I'll, for example, if these holes are going to be machined in a different setup and we don't want these holes in this part, I could delete those holes out of there. All right, so this would be now our manufacturing model. All right, but the best part of this linked body is that we're not making changes to the original design model. We're just making changes to the linked body. However, since this copy is associative, this linked body is associative, if I make a change to the design model, for example, the linked body will automatically update. And I'm going to show you an example of that now. So this is our linked body. I'm going to make a change to the design model. We can see here this is triple clamp.prt. This is our original design model, and I'm going to make a simple change to this. So this is maybe something that a designer or engineer may do. So make this big enough where we can see a difference here. All right, now I'm going to go back into our manufacturing setup. We notice that change took place in our manufacturing model as well, because this is associative. I had that associative check marked when I made the linked geometry. All right, and I'll go back into there and delete that change. And then I'll go back into our manufacturing model, and that change is gone. So you can see where this is a good way to create your manufacturing model. It just makes it nice that you can have that be associative back to your design model, but actually make changes without making changes to your design model. All right, so what we're going to do to get started in manufacturing, I'm going to go back over to my manufacturing environment and in my geometry view, and first thing we're going to do to get started here is define our MCS, or our machine coordinate system. All right, and you can see now that this machine coordinate system is in the center of this hole, and then it's split between this bottom face and the top face. All right, and I can put that MCS wherever I want. If I wanted to, for example, put it up here on the top face, I can move it up there. What I want to do though is I want to center it between these two holes, these two outer holes. I'm just going to use between 2 points, between that point and that point. You'll notice it's centered evenly between these two holes. Then we need to define our workpiece and our blank. So I'll double click on workpiece, and the first thing I want to do is specify the part. Simply just click on the part and accept that. And then you'll notice we have specify blank. And these options here, these are the options that we have to define our blank geometry. This is the options that we want to use to define what we're going to be starting with. What's the material going to start with? And then of course the part is what we're going to finish with. So the first option is geometry. I'll talk about this a little bit more in detail in a few minutes and show an example of this, but basically if you have other part geometry within this part file or within an assembly, you can define that as your workpiece blank. We'll show an example of that here in just a little bit. Offset from part. This would be like an example if you had a casting and you wanted to offset this part geometry by a certain amount. You could do that here by just typing in an offset amount. Next option is bounding block. If you're going to start out with a blank block shape, let me change my background real quick here so you can see these a little bit better. All right, so you can see this outer shape. This is a bounding block. So if you're just going to start out with a blank rectangular block, this would be a good option. You can add material in any direction if your block is bigger than what the outer perimeter of the part is. You can change these in any direction, so that makes it nice. All right, so again, that's a good option if you're starting out with a rectangular block shape. Bounding cylinder, probably not a real good option for this part, but you can imagine like a cylindrical shape or like a lathe part. Bounding cylinder would be a good option. Part outline. This is a really good one. This takes the outline of your part and creates your blank geometry based on the outline of your part. So you could see this creates just the blank geometry around the outside of this part here. And again, you can add material to that if you need to. And then you can also offset this as well. So I'm going to offset this by 0.5 millimeter. Zoom in on this, and you can see that offset this by 0.5 millimeter. So good option there. A good use for this is maybe this might be like a wire cut shape, and you have like a wire cut part, and then you're going to do your machining to it. You could use this part outline for that. Part convex hull. This simplifies your part. It's basically a simplified convex shape. In the same way the part outline works, you can add to this by using offset. So I'm just going to add 3 millimeters to the offset of this, and it offsets everything by 3 millimeters. So another pretty good option. And the last one here is IPW, the in-process workpiece, and this is something we're going to talk about later on as well. But this references your in-process workpiece and sets that as your blank. So if you have a part that has multiple setups, you could take the in-process workpiece from one part and then import that into your current part setup and use the in-process workpiece in your new setup. And again, we'll go into a little bit more detail with that one here in just a minute. All right, and then specify check geometry. This is for if you have clamps or fixtures, like in your assembly. You could specify check geometry, and that will help keep the tool from interfering with any of your clamps and fixtures. So now what we're going to look at is how we would use the geometry option to create our blank. The geometry option basically uses existing geometry to define your blank. An example of that would be like the wire cut that I talked about. If you have a wire cut model, you could define that as your blank geometry. Another example would be like a casting or a forging. And that's what we're going to take a look at now. I'm going to show you how we can use the original design model and quickly create another model to represent a forging using synchronous tools. Then we can use that model that we created as our blank geometry. So I'm going to close this part and open a new model. Open up this original design model. I'm going to open the original design model. So what I want to do now is in the modeling environment, I just want to create basically our blank geometry of what maybe a forging would look like on this part. So I'm just going to make a copy of this. Similar to the way that I made a linked copy, and then I'll do my changes to the extracted body. So I'm going to use my synchronous modeling tools again. And let me delete this hole as well. All right, and then I'll get rid of these holes too. All right, and another thing I want to do is resize these blends down here in the bottom of this pocket. So I'll just use the resize blend. It's telling me that these are a R2. I'm going to change those to an R6. All right, and now to simulate what a forging might look like, I'm just going to offset this body by about 2 millimeters, just for an example. Okay, so now you can see the use of synchronous tools. We're able to create a blank of what a forging may look like. All right, and we'll change the color of that. And now we should see our design model. So there we can see the green shape is the forging or casting that we created, and then inside there is our actual design model. So what I would do if I wanted to do manufacturing and use that as a blank, let me just start a new manufacturing file here. Just leave the MCS where it is. To specify the part, I would specify this inside shape, the actual design model. And then for our blank, we'll use geometry and select this green or the forging shape as our blank. So we can see the part and then the blank. So that's a nice way to be able to create our blank geometry. All right, the last option I want to talk about is the IPW option. This option lets you reference any in-process workpiece as your blank geometry. This can be very useful when machining jobs with multiple setups. This helps keep track of what you've cut and then the areas that still need to be machined by referencing your existing IPW. So let's take a look at an example of this. I'm going to open up this part here. This is IPW transfer part. This part already has some manufacturing done to it. All right, I'm going to show you what the existing IPW looks like. All right, the existing IPW we could see is this pink shape here, and you can see that this step shape on this cutout has already been done. These chamfers on the outside have already been done, and this cutout has already been cut all the way through the part. If we flip this over, we can see there's a couple step shapes on the outside of this plate. And by looking at our existing IPW, these haven't been cut. So we're going to reference this IPW from set 1 and reference that onto set 2. So I'm just going to open up the original part and start manufacturing. And you'll notice that NX puts underscore setup 2. It already knows that there's an underscore setup 1 reference to this part. So it automatically puts underscore setup 2 in there for us. All right. And since we're going to be doing machining to the other side, I'm just going to set my MCS, rotate it 180, since we're going to be machining the other side. Okay. And now we're going to go into our workpiece and specify the part. It's going to be the plate. Now when we go into our blank, we're going to use the IPW option. Select that. We need to tell it where we're going to get the IPW from, and we're just going to browse to that setup 1 file and use the IPW from our setup 1. Update that, and here we see the IPW came from setup 1. This is the same in-process workpiece that was in setup 1. Now we can see what needs to be machined, and then also we can create our operations based on this current IPW. Well, that's all we have for this session of NX CAM Lunch Bytes. I hope you found this information helpful. Please remember to join us again on May 16th for Designing in the Context of the Assembly in NX CAD, and on June 27th for NX CAM Turning Operations. More information can be found on our website at www.allyplm.com. I want to thank you for joining us and hope you have a great day.